Welcome to the last week of your online instruction. This lesson's on relays. Basically, a relay is going to be taking a control current or a low amount of current, making a switch connect, which allows the main current to do its job. So we're going to learn here that here's your coil. Now, I've already pushed the buttons here for you. I just wanted to show you. You're going to have to select each one of these: coil, soft iron core, the lever, and the switch. Operate the switch a number of times to watch how the relay works. So if you click here, you can see here closes. Here is touching the soft iron core, which allows the main current to come out and turn on the lamp. All right, now we're moving into part 2 or lesson 2 of this. The purpose of a relay is to switch a large main current using a small control current. A small switch can handle the control current without burning out. The relay contacts switch the current to the load and are large enough to handle this. A standard relay has 4 electrical terminals. These are 1 main current input, 2 main current output, 3 control current input, and 4 control current output. For example, relays can be used to switch current to the starter solenoid, horn, or headlamps. The screen shows a schematic symbol on the relay. Draw the diagram. Okay, so basically we're going to draw this. So we're looking at all the connections here. So 86 must connect up here. 85 connects down to the switch. Switch here to the lamp. And that basically connects in this wiring diagram what we actually see here in this visual. Click on the connections of the relay in the schematic view to the right of the actual view through which the control current will flow. So first, this switch is on the negative side. So it's a negative side switch. And we're looking for the control current. There we go. All right. So the control current flows through 86 and 85, as you can see there. Click on the connections of the relay in the diagram through which the main current flows. Well, it has to go through, this is the control current, which would close this switch here. So this must be where our main current is going to be flowing through to get to the lamp. So correct, the main current flows through 30 and 87. So 30 and 87 is the main current. 86 and 85 is your control current. Okay, connect the relay so the lamp is switched via the relay. So if we're looking at all this right here, we can see we need to connect our ground to our switch, our ground to our lamp here and here. We need to connect our switch to post 85. And then we see our positive side going to 86 and 30. So we need to bring positive up to 86 and positive up to 30. And now 87 is our last one, must go to the lamp. Once the switch here is activated, the lamp would turn on, and the switch is in here between 30 and 87. Okay, operate the switch. So come over here and click on this. Which statements are true? The control current flows through the connections 30 and 87. Well, we just found out 30 and 87 is our main current, so that can't be true. Operating the switch causes a control current to flow through the coil. The coil becomes magnetic as a result. That's true. The main current flows through 86 and 85. Well, we know that's the control current, so that can't be true. Operating the switch turns the relay on, causing the main current to flow. And that happens, yes. Okay, measure the control current. This is the current that flows through the coil. Now this here gets a little tricky. We got to measure for amps. So remember to pull your lead over, bring it down to amps. Here we're going to be checking with our lead on, come on, stick. There we go. Onto the negative post. We want to create a current through the switch to see how many milliamps we have without turning on the switch. If we turn on the switch, you'd have power and you could run the risk of blowing the fuse in your meter. So it's given a low voltage, it's asking for the voltage, but it's asking for it in milliamps. Now you might want to think of putting in 1.2, but this isn't going to be right. It's basically flashing between 10 and 14, so we're going to go with 1.2. It's the average. But let's just see what happens when you do that. It says incorrect. You need to show in milliamps, or 1 milliamp is 0.001 amps. So that's down in the thousands. So we got to move our decimal point over 1, 2, 3 places. So if we move our decimal point over 3 places, we have 1, 2, we need to add a 0, and it'd be 120 milliamps. Our decimal point would then be here, whoops, here, but we don't need a decimal point for this. So, all right, so it's 120 millivolts. Now, that could be a little bit confusing for you guys, but I'm sure you'll be able to follow along and figure that out. Now you're measuring the main current. Now, if you put it on negative here, you'd run the risk of blowing a fuse in your, you're not testing this correctly, blowing a fuse in your meter. Like if you put it on here or here, you would blow the fuse, as you can see here. So let's reset that. And what is happening is we don't put it on this lead. We need to get on the 2 sides of the switch to see how much power is going through the switch. So we know 30 and 87 are the main power, and there's that switch that's in here to get the main power to go through to light up the lamp. So we're going to put our leads on each one of these 2 sides, and that jumps the switch, because remember, there's a small amount of amperage, 10 amps right here, that the meter can give to show how much power is going through something. So here we can see about 8 amps. So you can see that the small control current is used to switch a larger main current. So we have 120 millivolts going through this switch which magnetizes and closes a switch in here, which allows the main current to flow through to the lamp, which is 8 amps. All right. Now we're going on to part 3 of the lesson. Here is this redrawn